Hey everybody, Matt Morgan here. In this lesson, we're going to talk about percent abundance from OpenStax section 2.3. We'll go over a few definitions. We'll focus on what an isotope is, talk about percent abundance and how to find it, and then work some sample calculations. Homework problem 23, which is assigned from chapter 2, and then example 2.5. So if you've watched the periodic table video, you know that each block has information about the elements. Most periodic tables show the element's atomic number, symbol, atomic mass. Some may even give the name. And that's where that information is located. Atomic number is the number of protons in the nucleus. The atomic mass is the sum of the protons plus the neutrons. So why is the atomic mass not a whole number? Can you have a fraction of a neutron? Well, it turns out that if you have a sample of any element, let's take carbon, it could be coal, it could be a diamond, not all of the carbon atoms in that sample have exactly 6 neutrons. They all have 6 protons, or else it wouldn't be carbon, but some of the atoms will have 7 neutrons, some will even have 8. The atoms that have different numbers of neutrons in the nucleus are called isotopes. They have the same number of protons, otherwise they would be a different element. But if it's the same element with a different number of neutrons, those are isotopes. So carbon with 6 neutrons is carbon 12, because 6 protons plus 6 neutrons is 12. And the symbol, you'll see a 12 in the upper left-hand corner. If there are 7 or 8 neutrons in a nucleus of carbon, the symbols are carbon 13 and carbon 14. You may have heard of carbon 14 used for radiometric dating. The number that appears in the periodic table is the weighted average of different isotopes in a sample, and we'll talk about what that is. But first, a warning. At this point, we're going to start to do more calculations.
No! No! No!
Some people might not be math people, but don't panic. Solving problems is a learned skill, and if you're not good at it now, you will get better with practice. It may take some time, maybe some coffee, but you can get this. Okay, back to the weighted average. That decimal number is the weighted average. We find that average mass by multiplying the masses of each isotope by the abundance, and then we add them together. All right, so what's the abundance? The abundance tells us how much of a specific isotope is in a sample. Abundance is expressed either as a percentage or as a decimal number between 0 and 1. So let's look at the formula to calculate average mass. Average mass equals the abundance of isotope 1 times the mass of isotope 1 plus the abundance of isotope 2 times the mass of isotope 2. And if there's more isotopes, there'll be a specific mass and a specific abundance, and you just add them all together. So let's look at homework problem 23. It involves 2 isotopes. You get one that's bromine 79. Its abundance is 50.69%. The mass is 78.9183 AMU, and AMU stands for atomic mass units. Isotope 2 is bromine 81, an abundance of 49.31%, and a mass of 80.9163. So let's plug those in. Our average mass, the abundance. So 50.69% equates to 0.5069. The mass stays the same. Isotope 2, the abundance is 0.4931 times its mass. The rest is math. Check my calculations on this. I may make a mistake and then say, oh, I'm seeing if you're awake. So I get 40.0037 plus 39.8998 We won't use this many significant figures in our final answer, but you want to carry extra digits and then round at the end. All right, I get 79.9 atomic mass units, 4 significant figures based on the 4 digits in our abundance. And that's homework problem 23. Let's look at example 2.5. We're going to use the same formula, but what they do is they give us the average mass and they ask us to find the abundance. So what I'm going to do, example 2.5 works this kind of problem. I'm going to work through the check your learning problem that's right below that example. It has the given information and the answer. So we're given an average mass of 63.546, a copper 63 isotope with a mass of 62.9296, and a copper 65 isotope with a mass of 64.9278. So let's plug this given information into our formula. We're going to solve for the abundance of isotope 1. They give us the mass. We also have to solve for the abundance of isotope 2, and they give us the mass. But wait a minute, it looks like we have 2 unknowns, but both of the abundances add up to 1, or 100%. So let's call abundance of isotope 1 X. That means the abundance of isotope 2 is 1 minus X, because X plus 1 minus X equals 1. So we have X times 62.9296 plus the quantity 1 minus X times 64.9278. So this, you'll have to brush off some algebra skills that you may not have used in a while. There's our equation from the previous slide. There is some algebra, but at least we have one equation, one unknown, and we can solve the problem. So 63.546 equals 62.9296x. We just multiply those together. For our second term, let's multiply through that 1 minus x. That gives us 64.9278 minus 64.9278x. Let's combine some terms. Both of those x values we can put together. That gives us 63.546 equals our number without an x, our constant, 64.9278 minus 1.9982x. And once again, check my math on that. Next, let's subtract that 64.9278 from both sides to get our x term on one side of the equation. That gives us a negative 1.3818 equals minus 1.9982x. Finally, we'll divide both sides by minus 1.9982, and I get x equals 0.6915. That means that the carbon-63 abundance is 69.15%, and if we subtract that from 100, our carbon-65 or copper-65 abundance is 30.85%. And that's how we got the numbers in the answer. Boy, that was a lot of math, but the good news is after you look at these problems, the quiz, midterm, and final are all based on the homework. You might have to work an average atomic mass problem like that homework problem, but you will not have to solve for X on the midterm or the final or the quiz. So the most of the math that you'll have to do in this course, you'll add atomic masses together, you'll multiply and divide when you set up dimensional analysis, but not a lot of solving for X. So if you have questions, there's my email address. We have online office hours Tuesday and Thursday mornings, 9 to 10 a.m. The link is in the Blackboard menu. You can also make an appointment if these times do not work for you.